which is called Electrification at Scale, moderated by Bodipo-Memba, who is the Sustainable Communities Director at the Sacramento Municipal Utilities District.
Thank you, Brianna. Really appreciate the opportunity to moderate this great conversation. I'm going to go ahead and share screens here so folks can see the slides for today. So if folks could let me know if they can see. Can folks see the slides right now? If you give me a thumbs up. Great. So again, I just wanted to welcome everyone to session 3. Again, we're really focusing this session on execution. I know there's a lot of discussions earlier about planning up front. My name is Bodipo-Memba. I have the honor to moderate this really strong and talented panel. We have Josh Morejohn, Executive Director of Utilities and Engineering from UC Davis, Colin Mickle, Renewable Energy Manager for the University of California Office of the President Energy Department, and Meena, and I apologize if I messed up your last name, and Venkatraman, who's a master's student with the Energy Graduate Group. We're going to have each of the speakers do their presentations one at a time for about 20 minutes per, and then at the end we'll open up for about 20 minutes for Q&A. And so again, if we could just have questions actively in the Q&A throughout the presentations, I'll be tracking those, and then we'll be moderating those questions at the end. So that way we can take full advantage of the great speakers that we have. And so first, we'll start off the presentation with Josh as our lead speaker, and just a little bit of background on Josh. Josh is, again, the Executive Director of Utilities and Engineering for UC Davis. He's been working to develop innovative energy management strategies and supports his team in implementing a wide variety of energy projects across campus. He's a licensed professional engineer and a certified energy manager. He's received his BS in mechanical engineering from UC Davis, as well as a BA in Spanish. So thank you, Josh. I will let you go ahead and take control of the screen to share your presentation.
Thank you, Jose. I'm going to do this one in English, though, if that's all right. All right, let me know if you can't see it. I think I'm sharing the right screen there. And I want to just start off by saying I've been super impressed with our presentation so far. I've been involved in helping with this conference over the past 3 years. We're on our 4th annual now, but I have to say this year, Nico from my team did most of the heavy lifting, at least on the facilities end of things. So I want to give a shout out to him for pulling together a great group of speakers and a great agenda. So we're on the section that's talking more about execution. A little caveat, because we've heard about some people who've done some great stuff already and are doing some great stuff. And what I'm going to talk about now is really the Big Shift project, and a number of you have heard of that already, what we're doing on campus. And I'm in this section because we've already completed now the first piece of that, and want to talk ultimately about some lessons learned. But I wanted to also just cover it from the perspective of how we were able to execute this project, and kind of the big picture in terms of even getting campus support for it. I know there's a lot of questions. We get a lot of questions and share with other campuses about the process, how to get administrative support and how to get funding and these kind of things. So, I would sum it up: pay now or pay later. It's a little simplification, but ultimately that's what you want people to understand, is that this is the best investment you can make, is a shift to this type of system. And I'm going to explain what that means in general, electrification, but you also need to do it in the smart way. And I think in our campus's case, that meant really leveraging the district energy systems we have. So let's see if I can get my slides advancing. So this is the Big Shift, how UC Davis launched a district energy transformation. There's a picture of our steam plant on the left there. We still have our steam plant, so we're not done with this. We've just started, and I'll get into what scope we've completed and what we've learned from that and where we're going with it now. But if you don't know UC Davis, since this is a global workshop here, just to give you guys a little background on the campus, this is our main campus here, but we are on about 5,000 acres, over 5,000 acres, over 1,200 buildings, about 12 million square feet total. About 8 million square feet and 120 buildings are on our district heating and cooling systems. And our annual utility bill has been around 25 million annually, probably going to be a bit higher than that this year with the way commodities are going. And just for size comparison, about 40,000 people daily showing up on campus. At least we're back to that now. In terms of electrification, you know, the big question people ask is what's your electricity supply? David Phillips could speak to this more there, and we're going to hear more about it in the next presentation with Colin. But the UCOP has done a lot in terms of renewable energy supply for campuses. We have also an on-campus solar farm. You can see here, David Phillips had something to do with that when he was working here at UC Davis. But that large solar farm, 16 megawatts DC, supplies about 15% of our annual electricity usage. So it's a piece of it. And then we have another about 30 megawatts off campus that is also feeding into our overall portfolio. And so we are very close to 100% fossil free. We also get some hydropower through our provider, electricity provider. And so for us, the big question wasn't really how to green up our electricity. We're very close to that. We're confident we're going to get there in terms of our goals. But the challenge for us is really more on the gas side, which is largely tied up in our district heating system, which is a steam heating system. On the right there, you can see our heating system largely mirrors our cooling system in terms of the buildings that are tied into it. They're similar size. The heating system is steam with condensate return, powered by 4 boilers. Now 3 boilers actually, because we've decommissioned one. We have these chiller plants, 2 chiller plants feeding into a cooling loop. And the key here is that these 2 systems historically have always been completely separate. But if you're on a campus with district energy and you have heating and cooling, there's a huge opportunity there to tie those 2 systems together. And that's what Stanford talked about as well. As I said, other campuses like Stanford, UBC, Vancouver have done this steam to hot water conversion already and have their story to tell. But for us, there was a really big opportunity with, as you can see from this chart, with heat recovery. And like Jerry's chart, this is showing cooling load over the course of a year, with blue on the top and red on the bottom in terms of heating in red and cooling in blue. You can see we have a lot more cooling load in the summer and the heating is in the winter. But the fact is we have a lot of potential for heat recovery, and that's what's shown with the light blue and on the orange. It's showing the cooling load that can be basically captured for heating. So you know, you have to change the way you think of your cooling system and realize that it's actually a heat collection system, and you're collecting heat from your buildings. And if all you're doing is running cooling towers to reject that heat, you're just throwing that heat away, which makes sense because it's really low grade heat. But when you tie into a hot water system with heat recovery chillers or heat pumps, now you can step that up to a useful heat temperature. And that's what we're looking at here with this chart, is about 60% of our heating load can actually be met with heat recovered from our cooling system. So for us, that became the big opportunity. We've been looking at this for about the past 10, 12 years. So it's exciting. We've got some action on it now. This is our consultant put together just a graphic that kind of shows that opportunity, that when you have district heating and cooling, and you have storage, really key component there. We heard about that from our Danish counterpart, and the opportunity that you have when you go to thermal storage. But when you do that, there's a lot of ways you can share that heat. And this is just showing that various low-grade heat sources, various opportunities for heat recovery between the systems. And a lot of that is enabled with a water-to-water heat pump or heat recovery chiller. So we looked at a lot of those opportunities. the big one for us was our cooling system, that we already had all this heat we could use. We looked at our existing steam system. This is a life cycle cost analysis. I'm not going to spend a lot of time on it, but this is part of the master plan effort that we did that I highly recommend. But the solution is really not that hard to get to. What this shows on the far left is the existing steam system. Ultimately, if we're going to keep that, we're going to have to replace the whole system. For us, we were at a crossroads. The steam system was old and needed to be replaced, much of it, about 60, 70 years old, and parts of it were failing, and we were spending more money on that and had plans to spend a lot more over the next 10 years. And thankfully, we were able to get the campus on board with the idea of let's not invest in that steam system any more than we need to. Let's spend that money on something that actually gets us where we want to go. And so you can see this is showing different types of expenses with the CapEx in the gray, maintenance in the orange and white stripes, and then orange being natural gas operating expenditure, electricity in yellow. And then there's some water in there, and then on the top is the green carbon costs. This is over a 60-year life. So really, this is really just a comparison number, not an estimate of actual expenses, because who knows? But it includes a lot of escalation. It includes, we did a lot of sensitivity analysis and found that a lot of the potential variables didn't really change the fundamental analysis here and the decision point, which is to move to hot water. Every other option on here is using hot water. And the big question for us became, as Berkeley looked at as well, is should we go distributed plants or a centralized system? The argument for distributed plants when you have a chill water system is that you already have this heat collection system. Why put in another whole distribution piping system if you could tie in local heat pumps to that chilled water system and extract heat from it where you need it? The challenge for us with an existing campus the size we are is the number of heat pumps, the electrical infrastructure that would be needed at the building level to support that, and the maintenance that would be required for that much equipment, new equipment on campus. And so while we're still keeping that as a local solution in certain areas, that is a distributed heat pump or heat recovery chiller that could provide a local heating district using our central chilled water. We saw it was in the long run more feasible and more cost effective to install the hot water piping, have a centralized heat recovery chiller plant that ties into our centralized cooling system as well. And there's some other options shown on here, but what is important is that this hot water system with heat recovery was not only a big opportunity to save energy with the low temperature hot water compared to steam, less losses, the heat recovery potential, but it's also a pathway to full electrification. And so that's the path we're on. What we've done already, this is just kind of a summary as why hot water is the pathway to clean energy for us. It's an opportunity to ultimately get off of our gas-fired boilers and our steam system. We've begun converting. I'll show you the scope of what we've done so far. And the next step is to put in the heat recovery chillers and add more buildings to our hot water network. And then full electrification will require more heat source a low-grade heat source in the winter, which we've done a study on that as well. And the best option would be a geo-exchange that similar to what Berkeley was talking about, where we'd do boreholes and run the chilled water down into the ground. So when we can't collect enough heat in the winter from the buildings, there's not enough cooling going on, we could warm up that chilled water in the ground. So we're still making chill water, but instead of cooling the buildings, essentially we're cooling the ground and then using that chill water return to run our heat pumps. And that would be the most cost-effective way to do it in the long run. You could also extract heat from the air with air source heat pumps, because all you have to do is get that chill water up to 60 degrees to run your heat recovery chillers. This is the campus, the main campus that's on district heating and cooling. The red piping is showing what got installed over the last couple of years, about 30 buildings. connected back to a steam to hot water heat exchanger, which we got from Stanford. Thank you, Stanford, for at least for the initial stages, we're able to make the hot water with our steam. And this, the benefit here, and part of why I'm giving this presentation is that breaking it into these districts enabled us to get going on it, to get some pipe in the ground, learn lessons, get buildings converted, and start working on that piece of it while we start to design the rest of the campus. And so the next phase we're doing is the yellow one shown here, which is going to get about the north half of the campus onto hot water, and also tie into the heat recovery chillers we're going to install at the chiller plant to replace our oldest two chillers. So another avoided cost there. Just to summarize, I'm going to show just an overall schematic of what our current or previous system looked like. We had two chiller plants and a boiler plant feeding into a distribution system shown as just typical buildings on the right side. And the two systems here are completely separate. So we've got a chill water system doing cooling. We've got a steam system doing heating. There's building heat exchangers in all the buildings making hot water. Most of our buildings, 99% of them are all hot water in the buildings, heating hot water systems in the buildings. And so we didn't have to do much work in the buildings themselves. We just needed to tie into that with our new hot water system. So the new hot water system, this is what the full final system is going to look like. Right now, all we've done is put hot water in two buildings. This shows heat exchangers, which I'll talk about in a second. We don't need that everywhere, but essentially heat exchangers to heat the hot water in the buildings. We're going to be installing these HRCs, or the heat recovery chillers, in the chiller plant, and ultimately have more of them. Initially, we're going to start with two. We're going to install a hot water thermal energy storage tank. We already have a chill water thermal energy storage tank, and that really enables the heat recovery, where we'll be able to do cooling during the day, collecting that heat and storing it in our hot water tank, and then running the hot water, meeting the campus demands at night and in the morning when we need heating. And that's pretty much year round. We do heating because of our temperature swing. The boilers are going to stay as long as we need them, but ultimately they will be phased out and replaced with the full electrification plan. They would be replaced with other sources of low-grade heat that we could use in the winter, and run heat recovery chillers for all of our heating. And that low-grade heat would be, like I said, either geo-exchange with some wells in the ground, which could also be used for heat rejection in the summer. That showed connected to our chiller plant as well. And then also potentially air source heat pumps if we wanted to heat that chill water in the winter when we can't heat it in the buildings. So that's just an overall schematic of the system. And as far as what happened over the last 2 years, the pipe went in the ground. This is one difference from what Stanford did. We learned a lot from them, and have tried to do what we can to follow in their footsteps. But one thing we did differently is we ended up going with a high temperature HDPE pipe. So it's a plastic pipe that can go up to 180 degrees operating temp. Which made the installation a little easier, just using fusion welding, and that pipe is installed in these trenches. We learned a lot from the trenching, and there was a lot of fear about whether we'd be able to get big trenches through the campus with so many utilities in the ground already. It wasn't easy, but it is possible. And in the buildings, we put, as I said, these heat exchangers. This is showing before it was insulated, a brazed plate heat exchanger, where we're bringing in the low temperature hot water from the loop and heating hot water in the building. Here's another mechanical room showing some pump stations, heat exchanger stations after they're done. And what we found is that we didn't need heat exchangers as much as we thought. That was one of our lessons learned, and I'll talk about that. This is the larger steam to hot water heat exchanger at the district level that right now is providing hot water to the campus using our steam system. This is one of the stations we got from Stanford. And so I just wanted to end with some lessons learned, and then you guys can bring your questions at the end of these presentations. But I would say one thing that we hear a lot is it's too expensive. It's too big of a project. And our approach was really do the master plan, really important to do that up front, have the big picture plan, but break it into districts. And I think that was key for us being able to get the ball rolling is we were able to find enough avoided cost and enough renewal cost already built into our 10-year plan that we could divert that into getting this hot water project going instead of spending more money on the steam system. And then key to that, though, is you got to keep it moving, because you can't just have part hot water, part steam. So the goal is that as each project finishes, we've already been working on the design for the next district and can keep the implementation going. That's obviously challenging, but I think that we've found that we've got a lot of momentum now with this first project done, and everyone's getting excited about getting the whole thing done. Another lesson learned was get stakeholders involved early. And by that, I mean people in the buildings, all the different people that might be involved in the system in the end. So I'm speaking from the utility side, get utilities operators and underground construction crews involved in the project, because it'll make the project go easier. And you can learn a lot from them and their experience that'll help out in the implementation phase. Even getting your building facilities guys involved early, because you're going to have issues in mechanical rooms and operations side, that it's really important to get their input as well as early as possible and get the buy-in. Getting everything on the table means there's really an opportunity, and this ties into, I think, the next one as well. Look at all the opportunities that you have with getting this new district energy system in, and we're doing that especially now as we're looking at with all the UC campuses, what it would take to go fossil fuel free, and looking at opportunities to get off of natural gas where it makes sense. And when you're putting in hot water, that's a great opportunity to look at, where do I have boilers? Where do I have package units that I might be able to get out of that business and tie into a much more efficient and ultimately renewably powered district energy system. So look for those opportunities, and that's where you can leverage some of your routing choices. Part of the communication with the campus, getting campus planning involved, and the various stakeholders, is that you can do a lot of coordination with these type of projects, where you can coordinate your routing to line up with other projects, whether it's road projects or other capital projects, and try to make them align as much as possible instead of being a conflict and an obstacle. A couple more technical ones. We get a lot of questions about the temperatures, and all of our building systems until recently were designed for 180 maximum heating temperatures for the heating hot water systems. What we did is a couple years before implementation, we turned them all down to 150, 155 maximum. We knew our maximum hot water temperature on the loop would be 160, and so we wanted to see how buildings would do with that as their max. And what we found in general is that 150 Fahrenheit works for heating buildings, at least in California. I can't speak for other places, but a lot of these systems are over designed on the heating side, two-row coils and more heat than they end up needing in the end. And so where we did have problems, it was often a plug strainer or airflow issue, and not a temperature issue. And so I wouldn't worry too much about that for people with at least with our kind of climate. And then the other big question we get, and one kind of surprising lesson, is the project in this first district wanted to isolate building systems from the loop system for good reason, that they wanted to limit the scope of the project and not have to deal with issues in the building that might be caused or exposed through a connection to the building heating hot water system, and running new water chemistry into a building that's been a closed heating hot water loop for 50 years. what we found is that with some cleaning of those systems using filtration and strainers ahead of time, we were able to get those heating hot water systems cleaned up and on the same water chemistry as the loop hot water. And we ended up not needing heat exchangers really. And so on our next phases, we're going to look at minimizing the use of those because it really simplifies it in terms of having to size the heat exchanger correctly. It's another piece of equipment that needs maintenance and additional controls and valving. So it really can simplify it if you can get away from that indirect connect to your buildings. So those are some of our lessons learned, and I will leave you with that.
Thank you so much, Josh. Really great presentation, and appreciate the photos of campus, of the work you've been doing. Definitely a number of questions that we'll come back to. Our next presenter is Colin Mickle. Colin is the Renewable Energy Manager for the University of California Office of the President's Energy Department. He oversees procurement of renewable energy renewable energy contracted through long-term power purchase agreements, as well as REC purchases on the spot market. Colin has a BA in political science from Pitzer College, an MS in community development from UC Davis, and an MPP from UC Berkeley's Goldman School of Public Policy. Colin definitely is the right person to have for this conversation. Thank you for your presentation.
Thanks, Jose, and good to see everyone, or at least see the names. I'll share my screen and also open with my enthusiasm for the live music we had. That was a first for me. I'm glad I got back in time from my lunch to hear a little bit of that. So there we go. Yeah, I'm going to be talking today about a little bit of a different side of the UC's energy supply, and this is basically what happens on the wholesale power procurement side. So giving a little bit of a trip back in time, I'm going to share the story of a procurement we did in 2019, and then talk a little bit later around what's changed since that time, and how has contracting changed for wholesale power purchase agreements, as well as what are some of the market forces at play that are changing the renewable energy industry. So I guess backing up and thinking about why we're doing this at all, I mean, everyone on this call, I'm sure, is aware that California has different aggressive, clean and renewable energy targets. So this chart kind of shows the different trajectories of the state. We have the initial SB 350 renewable portfolio standard, and then the updated SB 100 version, as well as the state's clean goal by 2045. And then finally, we have UC here leading the pack, 2025, with the clean electricity target. So that's sort of part of what drives a lot of the work in our office and why we do what we do. I guess first, just setting the stage in terms of, all across UC, we have a ton of behind the meter solar. Josh also, this is a great picture from UC Irvine. Josh just shared a photo from the behind the meter project at UC Davis. But today I'll be focusing more on the in front of the meter stuff that's on the transmission side of the grid. So this is a off-campus 5-point solar project. It's 60 megawatts located in the Fresno area, and UC is a long-term off-taker for this project. So there's really two primary reasons to be doing these long-term contracts. The first one is through the direct access program in California. UC runs a clean power program. So you can see on the map pretty much all the campuses that are involved. Some of them are larger accounts where we serve the primary substation, and then some of them are smaller accounts. And the program is zero carbon power as verified through the climate registry, provides cost competitive rates. We have 2 existing solar projects and an additional one that has been signed. Overall, this represents 40% of the system-wide purchased electricity. And then there's other benefits as well. So it contributes to UC's #1 standing for the in the EPA, as well as credit towards LEED certification, and then the essential regulatory compliance aspects. The other reason to look into the wholesale market and sign these long PPAs is what we call indirect access. So we're trying to fill that gap in terms of the whether it's the carbon content of power that's served from some of the IOUs, or the campuses that we're not able to serve through the Clean Power Program. We're going to be purchasing signing the PPAs and getting the renewable energy credits for those campuses to fill those needs. This slide just outlines the process and all of the the stakeholders that are involved. So we work closely with our governing board to approve the launch of an RFP, and then we organize external and internal support teams. So a lot of the people on this call have contributed to evaluating these projects, and then we also utilize the support of external consultants. So we develop bid criteria, we go through the RFP, we analyze and review the shortlisted projects, go back to the governing board, present those results, and then eventually work our way down to negotiating and executing the PPA. And I wish it was always as easy as those 4 words. This time, just showing again what a typical timeline might look like for this type of procurement, as well as some of the RFP requirements. So when we go out into the market, we're looking for new CAISO connected bucket 1 RECs. We're also looking for projects that are on previously disturbed land, and we want to be working with experienced developers. So from our 2019 solicitation, this is an overview of the results. So we had 30 projects that bid in overall. 24 were solar, you can see represented by the sun. We had 3 geothermal projects with the red thermometer, and then the 3 wind projects. So I also show some of the median hub settled prices from 2019. Those have all of those prices have gone up quite a bit since this point, and I'll touch on that a little bit later in the presentation. And then finally, we were pleased that the developers bid a lot of optionality, and this is partially at our request, but we like to evaluate multiple settlement points, whether that's at the actual P node, the interconnection point on the grid, or it's at the local hub organized by CAISO. Sometimes the projects have various COD dates, and then also flexible volumes where we could increase or decrease our commitment. What does the evaluation process look like? We consider quantitative and qualitative elements. So in order to do the quantitative economic analysis, we're comparing their bid price to an hourly forward price curve that was based on the current duck curve at the time, with a 1.5% escalation. And then we'd perform sensitivity analysis to determine more and less severe duck curve scenarios that could result. On the qualitative side, we're looking at the different bid characteristics. We consider the project's location in the grid, the experience of the development team, and all of that information, as well as some climate and equity considerations, feed into a final scoring outcome. All of those are summed up and ranked, and then we have a discussion of best fit. So this is at the time just showing we have solar, wind, and geothermal settling at different points on the grid. And you could see, at that time, and some of the least cost projects in the state were almost really at that $20 a megawatt hour, up through some of the sort of high to mid 30s, and then wind in this range, and geothermal $70 to $80 a megawatt hour. But if you take those prices and you compare them on a moderate duck curve scenario, you can see that pretty similar shape. but some of the wind projects shuffle around and move a little bit lower in terms of their overall energy value. You know, what is the expected lifetime kind of NPV of this of the project? And this is under a moderate case. And then as the duck curve scenario gets worse and we look at a severe case, wind really pushes up to the front. You know, and this is kind of as expected as the morning and ramp hours on the prices increase, that wind's generation profile, it just compares a lot better to those future scenarios. Of course, there's a lot of different factors that can affect project economics. When we think about long-term contracting, it's not a riskless venture. So we're signing contracts now for projects that often start 3, sometimes 4, sometimes 5 years in the future. And then those contracts go for 15 years. So they're, you know, it's a long-term commitment. And then UC's owing a fixed amount on the contract and is receiving a variable payment from the market. And then that variable payment from the market is being determined by a mix of, you know, what is the generation stack and the in the CAISO market, and how is that changing? How is that impacting power prices? So the net cost benefit of the contract also will be determined heavily by natural gas prices. Roughly, rule of thumb, about $1 movement per MMBtu in gas comes out to around $10 a megawatt hour movement in the power prices. I've mentioned the duck curve impact could be worse than modeled. And then often curtailments, which I have a slide on later, can happen earlier and more frequently than expected. Now, this is looking back at from what's changed since 2019 to now, is that the contracting, I'd say, is completely different. It's slowed down, and we're hoping that the Inflation Reduction Act will speed things up again. But there's a lot of new uncertainty that we didn't see in 2019. 2019 was probably the low point in at least solar and wind prices that we'd ever seen, and it hit that low and has bounced up due to, you know, COVID, the war in Ukraine, and then of course, you know, related supply chain impacts. There's also a lot more development risk, and so, we're seeing sellers have less price certainty. So they may not be able to offer a firm price when, and if they do offer a firm price, it may only be valid for a week or even a month. That's how much things are moving around. It's also more of a seller's market than before. I think previously the demand was maybe a little bit less. There were not as you know, the IOUs and CCAs were dominating the procurement. Of course, some of the well-known corporate buyers as well. But renewable energy developers were still hustling and trying to sell projects. Now that's shifted around a little bit, and I think there's a lot more buy interest, and the sellers have more leverage to dictate the terms more than they did in the past. We've seen the renewable power prices have gone up. The forward power curves have shifted, and the shift is, you know, mostly upward, with evening power prices are catching up to daytime prices. And then also we have a backlog in the CAISO interconnection queue and different delays to transmission upgrades. So just providing some visuals to the points I was mentioning. We have on the left is a chart comparing the European and the gas market. And as you can see, these huge price spikes driven by the war in Europe. And then on this scale, it almost looks like natural gas prices haven't gone up too much. But of course, you know, hovering around $8, this was before the end of September. That's going to have a big impact on the power prices. In general, the marginal MMBTU is going to Europe, and the US is looking to export as much as it can. And another way to look at the increasing power prices is in the in the futures market. So what was the cost, or what will be the cost of a calendar strip of power for, in this example, I think it's for SP15, all hours around the clock. So back in 2019, could have purchased that calendar strip for, looks like something around $30, perhaps $35. And now where we are, a few months or a month ago, that's gone up to closer to $90, almost $100 during some quarters. So that represents about 119% increase from 2019 to today. Also, as I mentioned, with the increase in gas prices, we're also seeing an increase in renewable costs. So just a few headlines here. We're looking at level 10, which tracks some of the solar, wind, and prices in the country, just showing that just in Q3 they saw a 9.6% jump. We're seeing year over year maybe 34% increases. So while the gas prices in the forward markets are up, so are the renewable costs. I think so. Alan mentioned curtailments on the grid and the risks of blackout, and this is just kind of further another way of showing those stories about actually how California is not able to always use all of the power we have available. The solar curtailments are climbing year over year, and then on the chart on the right, you can see that it's primarily those peak solar events in the middle of the day that the state does not quite have the storage capacity to be able to capture that excess solar and utilize it later in the day. So what are some of the lessons learned? I think the first one is the importance of working with experienced partners, and that counterparty quality really matters. So issues will come up and contract amendments are likely. I think when I started working in this role, I thought these events would be minimal if they ever occurred, and now I'm realizing that you almost need to expect them to happen, and they're quite likely just given the state of the market. It's also helpful to work with experienced legal counsel who can really play a valuable role in evaluating the contract. You want to know your product, so understanding the performance guarantees and the settlement terms, considering the delivery and curtailment risk, as I showed on the last chart where you see CAISO has having these increasing curtailments. The goal, of course, would be to sign a contract where you have as little as the gray curtailed power as possible. And then storage, I think in 2019 was really just a hot topic. It was in discussion. There were some PPAs being signed, but it wasn't as ubiquitous as it is now. So storage is here, especially for solar projects. Almost every solar project in this state is being developed with storage. So there's the developers consider the value of their interconnection, and they need to maximize that with storage. I also think the business case for wind paired with storage is developing. Right now, it's a little bit less clear if there's a market for that, but time will tell, and I'm sure the IRA will provide some interesting incentives. Also, the importance of negotiating a large development security. Of course, as the development risk increases, we want developers to be committed to the project. I say because UC is, we're here, we're committing to buy the power. So we want to be contracting with developers who are also committed to the contract. The old RFP and procurement style, kind of the one I laid out with that timeline, just doesn't work anymore. So the market forces are changing too quickly, and we need to find ways to expedite that process, condense the negotiations and the evaluation period, and then also increase bid deposits so that developers are at least upfront about what they can firmly bid and what they're comfortable committing to. With that, I'll say that flexibility is required from both sides. As a buyer, we also have to be flexible and understand that the developers only have so much under control, and be willing to adjust commercial operation dates if needed and if it really makes sense to do so. And then finally, I just added, the work is important. I think that's always a good reminder. Sometimes you get bogged down in the minutia of performance guarantees and security delays and things like that, and just trying to understand that, or remind yourself that the work's important is something that keeps me going. So with that, I'll pass it back to Jose.
Thank you, Colin. Really appreciate that overview. Definitely some questions for you in the chat that we'll get back to when we get through all the presentations. And I wanted to end here with our last presenter before we get to the Q&A. Meena, and again, Meena, I'm going to try your last name. Is it Venkatraman? Did I get it correct?
Yeah, that's great.
All right, thank you. So Meena is a senior research associate working with the Sustainable Operations Group at Berkeley Lab to support energy efficient technology adoption for federal agencies. Before joining the lab, Meena worked on campus energy efficiency projects and conducted research on affordable housing electrification as an energy systems master student at UC Davis. During those experiences, Meena particularly enjoyed exploring how to incorporate social justice and equity into energy-related projects. And given how important equity and social justice is in this work at the federal level and the state level, it's really important to hear what Meena is going to present. So Meena, I appreciate you joining this panel.
Great, thank you, Jose. I'll just share my screen. Yeah, so as Jose mentioned, I'll be taking a bit of a different direction, I guess, from the previous two presentations, but still looking at this idea of execution of electrification, and this idea of equity is like really applicable to all the different kinds of electrification projects, I think, that have been covered like in this workshop. And so I'm very excited to talk about this. And I think we all have some understanding of how social justice, or more specific to work, energy justice is really important, but it might be a bit hard to see the relevance to certain aspects of electrification, or we might not know how exactly to integrate this concept into electrification projects. And I certainly don't have all the answers today, but I'll just discuss some lessons that I learned while trying to incorporate equity in my energy-related work, and that will hopefully give you all a starting point for how to think about it and discuss applying it to your projects going forward. So I just wanted to briefly add a bit to my introduction about why exactly I'm talking about this today. I was a UC Davis graduate student in the Energy Graduate Group, actually just submitted my program requirements in September. And in between my first and second years, I interned with a nonprofit called the California Housing Partnership. And that's when I was researching how to encourage more affordable housing owners to implement decarbonization technologies. And I also ended up doing my thesis on a related topic. And this is where I really got to work firsthand on energy justice issues. And in my second year of graduate school, I helped my professor, Kurt Kornblith, and Josh, who you just heard from earlier, facilitate a zero net energy course at UC Davis, where we were trying to incorporate equity for the first time in this class. And I'll be talking about that a bit more later. So now I'm working at Lawrence Berkeley National Lab on how to encourage sort of a different group of people, mainly in the federal government, to adopt sustainable technologies through policy and outreach. And so the work that I do is definitely very tied to increasing the adoption of electrification technologies, which is necessary to address climate change. But I'm also really concerned with how that approach to electrification needs to center marginalized communities, and that's where equity comes in. So I just wanted to start first by mentioning that there's many different ways we might have heard of talking about equity. And when I think of applying equity to energy systems or energy projects, I personally like to refer to this definition from the Initiative for Energy Justice website. And I just wanted to point out that this definition talks about not just remediating the burdens on frontline communities, which means that we have to understand those burdens and impacts of electrification, but there's also this focus on achieving equity in participation or process. So we need to pay attention also to the design or planning stage as well. And my impression is just that a lot of times when we think about equity, we might think about more the consequences or impact side of it, rather than it being something that we incorporate throughout the process of our projects. So I just want to cover both of those aspects today. So I'm going to start out talking about what electrification impacts might actually look like for marginalized groups by briefly going over my master's thesis research on affordable housing electrification. And I'll use this to explain why equitable electrification is so important and why particularly that focus on process is really important. And then I'll talk about how we incorporated an energy justice framework in the project-based zero net energy class, what our takeaways were from trying to do that for the first time. And that's to help answer this question of, well, how do we actually address those impacts to different groups that we've identified? And since the class included a variety of energy-related projects, my hope is that the lessons that we learned can be widely applicable for the different kinds of electrification projects you'll undertake. So in terms of electrification impacts, when I was beginning my thesis research, a lot of the studies that I saw out there looked at utility bill impacts for the average household in a particular region. It tended to be more high level, but when I was working for the California Housing Partnership, people talked about how just a few dollars difference on residents' monthly utility bills makes a huge difference, because these are residents that already face a high energy burden, meaning that the bills are a large percentage of their income. So for my thesis, I wanted to know, how will this particular household in this specific affordable housing property be impacted by electrification? And is that going to be very different than the household next door or in a similar property? So bringing more of a human scale to this understanding of impacts. And so these are the questions I was trying to answer for two different electrification scenarios. One was a HVAC electrification scenario, so switching out the gas furnaces with heat pumps, and also a full electrification scenario where HVAC, cooking, and water heating, where applicable, were all converted from gas to electric equipment. And my thought was that the results would have some implications for how affordable housing owners and policymakers should approach the electrification of low-income housing. Briefly, this is the method that I use for modeling the residents' bills, going from residents' raw energy consumption and bill data with existing gas equipment to estimating what their bills would be under each electrification scenario and normalizing for weather variations year to year. And these were the kind of results that I was used to seeing. So those higher level averages for what the energy consumption or bill savings would be. Some people might look at this and ask, well, based on my modeling, is electrification good or bad? Should it be done for this property or not? And my very little bit unsatisfying answer is, well, it's complicated. And I don't think that's maybe the question that we should really be asking anyway, because we know that widespread electrification is important for climate change. And if we don't prioritize electrification of low-income housing especially, then those residents could be subject to high or at least very unpredictable changes in gas prices, getting at this issue of stranded assets. So electrifying now is definitely important, and breaking down these modeling results by household can help us understand what kind of bill impacts we'll need to deal with. How can we deal with them when we know these buildings have to electrify? So what my modeling results told us is that there's a huge range in predicted bill changes, from a 73% decrease or savings to a 56% increase between the 78 households that I looked at. And electrification impacts can also look really different for properties, even in the same city, like the two of them over here, and even households in the same property. About a third of the households that I looked at would face bill increases after full electrification, including 11 households across these two properties, where the average household is predicted to have bill savings or decreases. And as these are all residents whose energy bills are already a high percentage of their income, we should be definitely concerned that they would get left out of the narrative if all these electrification decisions are based on the average household, or even worse, if the decisions don't consider bill impacts to residents at all. So for one property, I had bill data that was available before and after a HVAC electrification retrofit. And this was how my predicted results from my model compared to actual post-retrofit data after electrification. I was expecting to see some differences since the model I used was just a simple linear regression, but some of the households with really large, like around 300% increases, despite predicted decreases, definitely surprised me. And when talking to the owner of this property, they mentioned that resident turnover, faulty equipment, And especially the pandemic causing more people to stay at home could help to explain some of these large differences. But unfortunately, I was unable to get more data to verify whether these factors were indeed responsible for the differences. But really my main takeaway from this is that the importance of not only predicting what residence bill changes may be, but also following up afterwards, monitoring bill changes, and providing support to residents who are facing much higher bill increases than expected. So the other takeaways that I highlighted in my thesis were mainly related to the need for more granular data collection and balanced policy aims. But the main thing I wanted to highlight related to equity is the need for equity to be incorporated early and throughout the electrification process. When executing electrification, equity is not just something we can really tack on at the end of the project. Like in this situation, for example, all we can do is really monitor bills after electrification and offer support, but there's actually other things that we could have done throughout the timeline of the project that would prevent us maybe from getting to such a state in the first place. For example, would many households have faced sort of unexpected bill increases if we had incorporated solar or more energy efficiency, if we had involved residents more and engaged them through education and outreach throughout the process. So those are the kind of things I'll be talking about next. How do we basically do something or take action to avoid these adverse consequences? And I'll do that by explaining the framework that we applied to the Zero Net Energy class. So in this class, the students worked in small teams on projects with UC Davis and or outside clients. And the project topics included campus building energy audits, home electrification, and electric vehicle charging infrastructure, with the intention that the projects would reflect topics that are at the forefront of conversation in the energy industry. So this year we did have quite a few that focused on electrification and decarbonization. And initially the idea was to have a class session to introduce this topic of equity, what it means, and to get students thinking about how to incorporate it in their projects. We also talked about including students' approach to equity as part of the assessment criteria for their presentations and report. And the idea was still pretty vague in the planning stage. Luckily, there was an environmental justice fellow, Adora Ifabi, at UC Davis, who reached out to my professor about collaborating, and she was open to hosting this session and coming up with a framework that we could ask students to apply to their projects, which would provide a more structured approach. So this framework outlined 3 dimensions of equity. The first one is procedural equity, which embeds inclusive, accessible, authentic engagement and representation in processes to develop or implement programs and policies. The next one is distributional equity, which ensures that programs and policies result in fair distributions of benefits and burdens across all segments of a community, prioritizing the highest need. And the last one is structural equity, which institutionalizes accountability so that decision-making recognizes the historical, cultural, and institutional dynamics and structures that have disadvantaged subordinate groups. And I'm paraphrasing a bit from the original document. But I will note that these dimensions are not and should not be set in stone in any equity framework you adopt. I've come across literature since then that talks about 4 dimensions, a couple that are not mentioned here. So I think any framework you adopt should be sort of continuously revised and updated as the research evolves. But these were the 3 that we used at the time of the class. And we asked students to review their projects across these 3 dimensions and think about what changes they'd make or consider in response. And students got pretty creative about this. So you might not think about these concepts being that applicable to a project that was, for example, working to build a model for determining occupancy from Wi-Fi data to tune building schedules. But these are the considerations that the students on that project came up with. And I think one of the particularly interesting ones to us was this point about cultural inclusion. So for example, you might not think you need to schedule the buildings on during certain holidays, but Wi-Fi or other data might reveal that, well, there are people who don't observe these particular holidays, and so they might be wanting to work or use the building at that time, and the schedule should definitely account for those people. So I would encourage you to think about how equity can be incorporated in your project, even when at first it might not seem like these topics are that applicable. So one thing we wanted to encourage students to do also was to think about not just equity related challenges for the project, but also the opportunities. So what actions can you actually take in response? And for this project, students created a interactive display with signage and simulation using an existing miniature HVAC system. The aim was to help educate students, faculty, and staff about how these systems work so that they can apply this knowledge to saving HVAC energy use at school and at home. And here students went sort of beyond just identifying the opportunity to actually implementing them by making sure that their signage, handouts, and displays were all accessible. And we really wanted equity to be a topic in the class that was more than just discussed during one lesson and then forgotten about. So it was really great to see it applied in this way. For my last example, I just wanted to mention that all these slides are taken from the students' final presentations. And you might have noticed that the previous two were, the slide was titled Equity or Equity Components and just had that singular focus on the slide. For this particular project, evaluating UC Davis's existing electric vehicle charging infrastructure and proposing plans for expansion, the students actually sprinkled their equity considerations throughout the slides, from initial identification of stakeholders and all the way through their methodology and results. And so this kind of reflects the idea that ideally we should come to think of equity not just as something separate from the other elements of our projects, but actually integrate it into our thinking for each part of the project, like the students did pretty well here. And with that, I'll wrap up the examples from the class. So from trying to do this for the first time in the class, I think what worked was to bring in someone who had a lot of experience in this area and have them on board when you're trying to put together the framework. It also helped that the session where we introduced this framework was in the beginning, towards the beginning of the class in the second or third week. So students could start thinking about this from the beginning through to the end of their projects. And then as much as we like to think about this is a topic that people will embrace voluntarily, I do think it made a difference to make equity part of the evaluation process for the students' presentations and final reports, because there has to be some sort of feedback and accountability to make sure it goes beyond a surface level take on the topic. We also encountered some challenges, like in some projects, it was harder to think about equity than others. And I think in part that's because I didn't manage to talk to clients when I first was gathering project ideas about how we wanted this to be a pretty big focus in the class, since it wasn't a very fleshed out idea at that point. So I think that's definitely something I would recommend for the future. And I think it would also set the stage for more fruitful discussions with clients if students came up with additional ideas related to equity that weren't part of the original scope of the project. And then finally, I just wanted to reiterate the point about continually revising your framework and approach based on current research and also adapting it to your own needs. As I said at the beginning, I'm definitely not an expert in this, but I think that's okay. And we don't have to be to apply all these principles, because in this area, there's always something more to be learned. And as we continue to learn and grow, as should our approach to equity and electrification also expand and change with that knowledge. So yeah, thank you for listening. I'm definitely very excited to talk about this topic. So please feel free to reach out to me if you're interested in continuing the discussion, and look forward to the questions and discussion afterwards. Thanks.
Thank you, Meena. Great presentation. And I'd like to invite all of the speakers on screen as we get to the Q&A portion. And again, as you guys can see from the chat, our panelists have been active in responding, but I am going to re-ask a few of those questions just so that folks give them a chance to expound on some of the topics of discussion. So I'll start off with you, Josh. There was a question that came from Taylor about what the payback of the single axis tracking solar was compared to the non-tracking.
Yeah, and like I said, David Phillips, if he's still on the call, may have more to add, as he was involved in that PPA. But ultimately, we didn't make that choice. We just put out a request for proposal for this PPA, and we had certain requirements that we wanted to hit. And the one that we ended up selecting for meeting the production requirements that we had at the lowest cost ended up being the single axis tracking. So at the time, I think that was back 2011 or so, 2012. but at the time that was that ended up being the lowest cost solution. So I don't know if that would change right now, but it wasn't something we chose.
Appreciate that. I had a question for you, Colin, in the chat. The question came from Sam Zimmerman. Any sense of how renewable PPA prices are comparing to natural gas in the current environment?
Yeah, thanks, Jose and Sam, for the question. I think if I understand it right, I think he's inquiring about like natural gas on the generation side. So, of course, it's going to change depending on a variety of factors. What is the technology? Where is it located for the renewable, I guess, and the gas generator in terms of what type of a asset it is. I think as a general rule of thumb, renewables are quite a bit less expensive, but of course they only produce at certain hours of the day. So they're intermittent resources, whereas gas theoretically can run base load or peaking. So yeah.
Thanks, Colin. Meena, you have a question in the chat. It says, can you talk about how reducing overall environmental impacts does not target equity?
So I guess if I'm understanding the question correctly, I guess reducing overall environmental impacts, that is, in a sense, one way to get at equity if you're talking about sort of the distributional impacts of our wider like greenhouse gas emissions that we cause. We know that certain communities, environmental justice communities, are more subject to the harm that comes from those emissions. But I think when you're talking about equity on sort of a project level, there is a lot more that you can do within the project itself. That's kind of different from the scope of the project targeting those emissions. And so there's, just to take an example, like throughout the, like kind of what Josh was talking about earlier with involving stakeholders in the process and making sure that you're kind of talking to everyone who's involved, that not only lets the project go more smoothly, but it can also make sure that you're talking to people whose voices are maybe not heard as much in those kinds of projects and making sure that their perspective is included. I hope that kind of answers that question.
No, I appreciate that. Definitely is a lot of the work that we do at SMUD is trying to understand the more site-specific concerns in different communities. So I really appreciate that perspective. Meena, I have another question in the chat. Can you share any equity evaluation metrics you've seen in energy projects?
Sure, yeah. So that's, I guess for the class that we were doing, just the evaluating the students' projects, it was, I guess we weren't trying to get that much into like very specific metrics because this was just student projects and they had a limited amount of time and each project was quite different. So for us, we were just looking for whether they had evaluated their project across those different dimensions. And then also, had they made some considerations or identified these opportunities and challenges for equity in their project. And I think that's a good starting point, but yeah, there's a really good question about, what kind of specific metrics, especially like numbers, should we be looking at in order to evaluate equity? And I think that can really differ depending on like what kind of electrification project you're talking about. But for example, when I was looking at affordable housing electrification, one thing that I saw a lot was that, the way that people talked about whether this was going to impact these communities was just by that like average household, whether the average household's bills would increase or decrease. And I think what I was looking at kind of showed that that's not really enough because you need to see sort of the spread of impacts between even these households that are in the same property. They have very different experiences after electrification. So I think that's definitely like a very good question about, even if you're thinking about equity evaluation metrics, like that's a great place to start. And I don't know sort of the specifics for different types of electrification projects. But yeah, I guess there's a question for you, Jose, about that. Are there any that you use at SMUD? I'd also be really interested to hear.
I'm happy to just give a quick answer to that, but definitely don't want to go back here to the panel. But we are using some metrics to evaluate equity in our infrastructure projects. We actually developed an equity map when we call it our Sustainable Communities Resource Priorities Map. It takes a number of equity focused, environmental focus in indicators and identify some hot spots. And we use a number of information from the federal, state, local jurisdictions to help us target where those equity areas are. But to your point, Meena, once you get those hot spots identified, then it's a matter of actually engaging community members to understand those specific needs. But that's one tool that's being used. I know also at the federal level, there are some federal maps that are also focusing in that as well.
Yeah.
I wanted to ask a question back. Thank you so much, Meena. Back to Josh. Rachel had a question for you asking, what building level retrofits are you having to make to existing structures to accommodate for electrification?
Yeah, great question. And I do want to point out, I saw in some of the comments, we have two of our project managers from the project on the call, Alan Suleiman and Dan Goldie. So feel free to throw more specific questions to them and into the comments. But I'm glad they could be on here too. As far as retrofits, like I said, the project, as projects always want to do, they want to have a clear boundary and not have scope creep. So we tried to have that boundary be the mechanical room in the buildings. And so we didn't do retrofits in buildings for the most part, besides connecting them to the low temperature hot water system loop. Though there are going to be a couple buildings that do need retrofits. There were also some cases where, like for example, we had a steam coil in one small fan coil unit that served a classroom, one of our only steam coils on campus, and that had to get replaced with a hot water coil. And then we have a building with steam radiators that is going to have to be retrofit, and we're actually looking at some ways to do that outside of the project. But for the most part, the buildings could stay as they are. And then we're now looking, as we're getting into our first winter with these hot water buildings operating, we're looking at what we can do on the efficiency side of it. And some of these hot water systems haven't had a lot of that commissioning. Even though we've had these hot water systems in the buildings, it's going to be more important to have the higher delta T and make sure they're working well. So our engineering team is going to be looking at commissioning those hot water systems in the buildings as much as we can before we get heat recovery chillers online, where the delta T is going to become really important. So great question, but yeah, not any major retrofits. I think that's a whole separate project that is worth tackling, but I think it doesn't have to be done at the same time.
Thank you, Josh. I'm going to transition back to Colin. And Colin, another question that came from Tyler, and I know you started responding to it, but Tyler asked, are you seeing any variability in the T&D and local utility fees tacked on for campuses buying into the projects, or is it mostly just RECs to the campus?
Yeah, exactly. So for in the instance where we're not the direct load serving entity, and even when in the clean power program serving the load, we're acting just as the commodity supplier. So I know that different campuses have seen increases in their T&D. This largely should not impact that. So, and then on the indirect access side, similar case where we're providing the renewable energy credits and would be retiring them on their behalf.
Thank you, Colin. I'm gonna go back to Josh and then have another question for Meena right afterwards. Josh, Carol had a couple of questions. I know that Dan helped respond to some of these, but if you maybe can help expand on this. Carol asked, why wouldn't you retain gas boilers for resiliency? And then she also asked if she and the institution she represents could have the heat exchangers when you're done with them.
Yeah, you can't have them. We're going to have a little bidding war, maybe see what kind of price we can get. But no, like Dan said, we would love to see them find a home. He did point out that, the current plan is that we are going to keep we have 3 heat exchangers, and we're going to keep at least 2 of those for now, as long as we have the boilers, because it does provide us, right, we need that heat in the winter for now. And then if we do full electrification, it still could be a backup source of heat while we have the boilers. We're still going to have a question at some point in the future, when those boilers are end of life, what do we replace those with? If we need another backup source, or if we're fully electrified, do we have enough redundancy and resiliency built into the system? And like what was pointed out earlier, a gas boiler doesn't necessarily provide you with more redundancy or resiliency, as opposed to, for example, electric heat recovery chillers, if you do your system right and you have that redundancy and resiliency built into the electrification. So we at the moment, we're going to keep some of those heat exchangers. Definitely want to get rid of one of those in the next, I would say, 5 years, when we are able to turn off steam in that part of campus. But so keep in touch, and we'd be happy to see it find a good home.
Thanks, Josh. Mina, one question. Again, you talked about how it was difficult to incorporate equity in some of the projects, and you really emphasized having a conversation up front in the early planning stage to ensure that equity is adopted. I just wanted to ask, what kind of education you think is needed in this space so that it does become more second nature for that to be wrapped into the process?
Mhm. Yeah, I guess I don't know if people are interested to hear talks like this and get an idea of how to approach the subject. I think from my perspective, what was really helpful was having the sort of structure of a framework that you can go step by step and see what you need to do and when you need to do it. And yeah, I think if those kinds of frameworks are sort of become more common and become more inbuilt, like to a particular organization, for example, if that's sort of in their policy in the first place, that's one thing.
Right.
It's kind of more higher level, but I think when people really start implementing it on the ground, like I find what's helpful is like A, having that framework, B, having like specific clear examples where that's been done before. And so you can see like, oh, my project's similar to that project that implemented this equity approach in this way. I can probably do that over here. So just like more sharing of examples where it's worked, and also, when it hasn't worked, why hasn't it worked, and understanding that. So yeah.
No, I love that. And again, we're right about at time, but I really want to appreciate Mina, Colin, Josh for your great presentations and great information and sharing best practices. It's been very valuable, and representing SMUD, been a pleasure to facilitate this conversation. We'll definitely be looking in and working with all 3 of you down the line. Thank you.